Good morning, class. We are continuing our discussion of how do we collect data, bivariate data. That means that there's two numbers associated with one event and build a model for that data. Well, first of all, I think it's important to look at the data visually and decide whether or not we think there is a relationship. If it appears that the shape of the relationship is a line, it's linear, then we can go ahead and proceed with building a model for that data. What we've been doing so far is just picking 2 points that appear to be on, uh, 2 points that appear to kind of create a line that represents the general gist of what's happening in the data, and then using those points to come up with a line of best fit by just finding the equation of the line that goes through 2 points. We're going to continue that discussion today and tomorrow. And we're going to end up with the introduction of the least square regression line. We'll be talking about what that exactly is and how we can use that to come up with a line. Today we're going to, well, actually tomorrow, today our class is going to agree on a single line of best fit for any particular situation. We're going to start by looking at question 31. It says the following table shows data for one season of the El Toro professional basketball team. Clearly fictitious, but it sounds a lot like the Chicago Bulls. El Toro team member Antonio Cusack was inadvertently left off the list. Cusack played for 2,103 minutes. We would like to predict how many points he scored during the season. So here's a fairly long data list. This checksum just means that if we were to enter these points into Excel or to Sheets, at the bottom we can add them up and just see that these numbers were the same. It's kind of a way of checking whether or not we entered an error. We have an error in our data entry. Sometimes it's possible that you could make two errors that would cancel each other out. So the checksum's not a fail-safe, but it's at least one way to just verify that we're entering data correctly into a table. So we are going to be using the E tool and doing A, B, C, and D. The link for the E tool is in your ebook. So just go ahead and click on the question 31 E tool, and you should see this. And I think it'll look just like this when you open it up. If you want to focus on the data more, you can click this. For me, for the video, I like projector mode on because it's just they're bigger dots and it's easier to see what's going on here. There are these two lines. There's this purple line that has these two purple dots, and as I move them around, right, I can come up with what I think would be an appropriate line of fit. And in fact, my instructions over here are, well, this is what I just read. Here's the data that's entered for us. Very nice. And then it says draw a line of best fit for the data and then use it to write an equation that models the relationship. So it does say hint, drag the purple points to model a line of fit. So basically what I want you to do right now is consider these points and drag them around until you get to a point where you have a line that you think represents the data well. And then once you've got those 2 points, write them down in your notes. This is the notes that you're going to submit, and you can do this as a doc too if you want to type these up, and that's fine too as well. But this is question number 31. So for 31A, I should see probably a screenshot of this or a sketch of this if you're doing on paper. I would suggest a screenshot that you put that into your doc. For B, then I would like for you to list. For A, I think you also need to list the equation. So write down both of the points for A that you used, and then come up with the equation of the line that goes through those 2 points, and include that in your notes. Question B says, which data point is an outlier for this data? Whose data does that point represent? What is his residual? So if you look at it, there is a point clearly that's not in line with the general shape of the data. So you should identify that player, um, and that player, I think that player has a positive residual. So just for part B, just identify that one and talk about what that player's residual is. So for example, if you thought it was this particular player, right, what you would do is if you drag on here, you can get to where I want an X value of 2088. I think I can go to 2088, or I can get super close to it. Not as close as I want. That's pretty close. But you can see around 2088, 88. I've got a predicted value for my current model of 845. The data point right below that, that is at 2088 minutes of play, has an actual point scored of 351. So the difference between those two numbers, right? You would take the 845. Well, actually, we take the actual. So the actual is going to be 351, and we would subtract the predicted of 841 to come up with the residual. Again, that's just for this line that you're looking at right here, which I don't think is a particularly good line. But if you're asked to find the residual for an outlier, it says what data point is an outlier for this data? Whose data does that point represent? What is his residual? So a couple of things there, right? Tell me what player it is, what's their minutes of play, and what's their points scored for part B, and then what's his residual. To answer that question, what I'm saying is if you wanted to find the residual for this player, for example, you can just click on these points to hide or show the minutes of play and the points scored. But then if you click on your line of fit, you can bring it to a spot where you can see very close. I wanted to get closer, but you can get very close to 288. Well, wait, somewhere in there you play with it better, but that's close, and you can see that's like 712 points. So the residual, remember, is the difference between the actual value and what the model predicts. So if you plug in 2088 into your model, it'll tell you the predicted value. And then to figure out the residual, I should just see this number subtract what your model predicted. Um, could a player be more, would a player be more proud of a negative or a positive residual? So think about what that means in context here. What does it mean if you have a residual that's positive, clearly above the line? What do you have a residual that's negative? And I just want you to explain to me what would be better, one that's positive or negative, and then predict how many points Antonio Cusack scored. So based on your model, the equation you have, remember Antonio played for a total of 2,103 minutes. If you plug 2,103 minutes into it, what would be his approximate score? You guys, as you're doing this, I really recommend that you spin up a shared doc and that you're working on this together and that you're submitting kind of a group report. And you guys do know members, if you're away today, you do know people that sit in your group with you. Just go ahead and open up a doc, share it, and then send an email saying, hey, I'm working on math right now. This is, and I shared a doc with you, so let's jump in there and work on that together. All right, so that's it for question number 31. Let's take a quick look at 32. So my guess is that if you're working individually or if you're working as group, different individuals or different groups are going to come up with different models for the relationship between total points scored and minutes played. It's just we're just picking a line that we think fits the data well, right? And then based on those 2 points, we're coming up with an equation. That will also have different estimates for the number of points scored by Antonio Cusack. Your task, discuss with your team how you can decide which team's equation models the data best. Compare your team's model with that of another team. Which of the two models is better? We are probably not going to be able to do that. But I would like to just say that one of the things that I think we would look for is we could think about, we know what residuals are and we can see residuals for each player. Maybe the team that has the smallest residuals or the smallest average. Well, if I added up the residuals, I think that's going to equal zero. But if I added up the absolute value of the residuals, maybe the one who has the smallest absolute value of residuals would be better. This is not something you're going to be able to do, uh, but I'm glad that you listened to this and thought about this. How would we know which model was better? All right. Question 33, the final thing we're going to look at today. It says sometimes there are several different lines of best fit that can be drawn with the same sum of absolute values of the residuals. So if you're just adding up those residuals, um, the sum of the absolute values of residuals, you're going to have several different models that can still minimize the sum of the residuals. To create a single unique line of best fit, statisticians use the sum of the squares of the residuals instead of the absolute value to make all the residuals positive. So instead of taking the absolute value of the residuals, To make them all positive, they simply square them, and then we work on minimizing the area of those squares. This is going to be a very difficult question to answer, but I think I'm going to try to step you through how to do that in Desmos. So let's take a look at how you would answer what is the sum of the squares of the residuals for your line of best fit. Actually, I think I'm going to have to let that go. So what we'll do instead is I'm just going to end with this brief discussion. So if you can imagine, there's some situation here. I've collected bivariate data. This person had one of their measurements was 5, the other one was 1, 5, 1. And I've sketched what I consider to be a reasonable model for this data. The residuals, of course, are the distance between what the model's predicting and the actual output for those values. So I can draw all the residuals on here. There they all are. Some of these are positive. In fact, 4 of them are. 2 of them are negative. And the thing with the residuals, if I add them up, I think I'm going to get to 0. No, no. I think if, mm, well, the problem is that some of these are canceling each other out, and I could make this a horizontal line and still have a residuals that were adding up to 0, and it wouldn't tell me much. So what we do instead is we look at squares that are built on these. Now these squares, right, are resistant to being positive and negative, and what we do is, in order to find the line of best fit, we're going to be looking at the way to minimize the area of all these squares added together. So we'll call that the least squares regression line, the line that minimizes the sum of the squared errors, and that will be the line that we're going to use moving forward. More on that tomorrow. For today, it looks like it's just the question 31, and I'm looking for everything that I discussed in that part, and I will see you again tomorrow.